his theory of relativity, Albert Einstein predicted dense objects in space with so much compacted matter and gravity that not even light can escape them. These objects are called black holes. But if Einstein's theory only predicted them, what evidence do we have that black holes really exist? Well, I'm here to tell you. The first piece of evidence that I will be analyzing for you today is the existence of black holes in binary star systems, where stars can be seen orbiting an invisible companion, the black hole. These invisible companions emit X-rays, which is how they are detected. A great example of this is an X-ray source with high temperatures found within the Swan constellation, Cygnus, called Cygnus X1. The star Cygnus is a blue supergiant star of about 30 solar masses, which is pretty large. As you can see from this model on the screen right now, Cygnus orbits this invisible source, Cygnus X1. Since the star itself is so massive, it is reasonable to assume that its companion must be very massive as well. Yet, the companion was observed to be non-luminous. With the evidence provided so far, one might conclude that Cygnus X1 is orbiting a neutron star. However, the companion, through studies of revolution and speed, was calculated to be between 8 to 10 solar masses, whereas a neutron star is only about 1.4 solar masses. Therefore, it is way too large to be a neutron star. Thus, the existence of a black hole in this system is very probable and honestly the best explanation for what is going on within the system. NASA calls Cygnus X1 a stellar mass black hole, which are the type of black holes that form in these binary star systems. Stellar mass black holes are different from the infamous supermassive black holes in the way that most of their gas makeup is driven away in formation. These gases are detected via spectrograph as emission lines of a particular wavelength. As black holes orbit each other, the Doppler effect causes the emission lines to shift, where one black hole shifts to longer wavelengths and the other to shorter wavelengths. The next binary system we're going to look at is the variable star V404 Cygni. Similar to Cygnus, analysis of the orbit of V404 Cygni divulged that the unseen companion was between 8 to 15 solar masses, still much too large to be a neutron star. However, this star is a low-mass star, about 2/3 the size of our Sun. Because their gravity is so strong, black holes literally distort space-time around them. They redirect light and form accretion disks around them, which is basically just a bunch of hot gas. Interestingly enough, this black hole has been producing bursts of X-rays as it steals mass from Cygni. These X-ray bursts are not uniform because of this. As accelerating gas flows into the accretion disks, the brightness increases by 100 times. This picture shows the burst of new activity in 2015 and the pattern of X-ray echoes from the nova eruption. The evidence that I've provided for just these two instances of binary star systems are two cases that prove the existence of black holes. However, there's so much more out there. There's a whole universe waiting to be explored. So many instances of black holes that haven't been discovered yet. And even some that have been discovered and analyzed that I didn't go over today. Black holes are such interesting things, and the future only brings, and will only bring, more evidence for them. I hope you've enjoyed. Thank you so much for watching, and I hope that you've at least learned a little bit about black holes today.